Hey everyone, and welcome. Today we are going on an absolutely incredible journey. We're going to follow the secret life of something that's all around us, it's inside of us, and it literally makes everything happen. Let's dive into the amazing adventure of energy. So, to get our brains warmed up, I've got a little puzzle for you. Take a look at this slide. We've got a lightning bolt, a banana, and a bouncing ball. Now, what in the world could these three things possibly have in common? I'll give you a second. Think about it. Did you get it? If you guessed energy, you are 100% right. Energy is like the secret ingredient that powers our entire world. It's what makes things move and change and grow and light up. It is the powerhouse behind, well, pretty much everything. Now, as powerful as energy is, it has to play by one very, very important rule. You could call it the number one rule of energy's game, and it is a rule that can never, ever be broken. Okay, here it is, the official law. And I know it sounds a little serious, a little complicated, right? Cannot be created or destroyed, only transferred. But trust me, it's actually super simple once you think about it in the right way. Let's think about it with Legos. Imagine you have a big box of Lego bricks. You can't just magically make more bricks appear out of nowhere, and you definitely can't make any of them just vanish. All you can do is take them apart and rebuild them into something new. You can go from a car to a castle to a spaceship. The number of bricks you have always stays the same. Well, energy works exactly like that. So, if energy isn't created or destroyed, where is it all? Where does it hang out? Well, scientists call these places energy stores, and a great way to think of them is as different hiding spots for energy, or the different forms it can take. So, how many of these main hiding spots are we talking about? There are 8 of them, 8 different ways that energy can be stored up, just waiting to be used. And here's the whole list. Now, some of these are a little more complex, like nuclear and electrostatic. So for today, we're going to focus on the main ones, the ones you see and feel in your life every single day. First up, let's talk about kinetic energy. This one's one of my favorites because it's so easy to spot. It's really just a scientific way of saying moving energy. If you're running across a park, you've got kinetic energy. A baseball soaring through the air has kinetic energy. Even the wind blowing the trees has kinetic energy. Basically, if it's moving, it's got it. Okay, so what's the opposite of kinetic energy? If kinetic energy is energy in action, what do we call energy that's stored up and just ready to go? We call that potential energy. Think of it as energy that's just waiting for its moment. This slide shows the difference perfectly. That rolling ball, it's using its energy. That's kinetic. The ball at the very top of the hill, it is full of potential. A perfect example of this is gravitational potential energy. This is the energy that something has just because it's high up. A book sitting on a tall shelf has it, or, I love this idea, think of it as zipline energy. When you're standing up there on the platform, you're not moving yet, but you are packed with potential energy, just waiting to fly. Another kind of stored energy is elastic potential energy. This is the energy you get when you change an object's shape, like by stretching it or squashing it. The classic example is a rubber band. When you pull it back, you are loading it up with elastic potential energy. The second you let go, that energy turns into kinetic energy. A squish spring works the exact same way. So what about the energy that's powering you right now? That would be chemical energy. It's energy that's stored in the tiny, tiny connections between atoms. That banana from our first slide, it is packed with chemical energy. When you eat it, your body breaks it down to release that energy so you can run and play. Batteries and fuel are also just fantastic stores of chemical energy. All right, finally, for our energy stores, let's talk about thermal energy. And you know what? This is just the scientific name for heat. It's that simple. A hot cup of cocoa has a lot more thermal energy than a cold glass of water. The hotter something is, the more its little particles are jiggling around, and that means it has more thermal energy. Okay, so we know energy has all these different stores or hiding spots, but how does it move from one store to another? Remember our Lego castle? It doesn't just magically become a spaceship. We have to actually take it apart and rebuild it. That action is called an energy transfer. So let's look at the different ways energy can travel. There are 4 main pathways for energy to travel or transfer. A mechanical transfer is when a force does some work. An electrical transfer involves moving charges, like inside a wire. Heating is that transfer from a hot object to a colder one. And radiation is energy traveling as waves, like light coming from the sun or a lamp. So here's the key thing to remember. You've got the stores, and you have the transfers that move energy between those stores. Let's look at a simple, real-world example to see this amazing, never-ending journey in action. Let's follow the story of a simple flashlight. We start with chemical energy, just sitting there stored inside the battery. Then you flip the switch. That kicks off an electrical transfer, and energy starts flowing through the wires. It arrives at the bulb, where it changes into two new forms: radiation, which is the light you see, and thermal energy, which is why the bulb gets warm. See? No energy was created or destroyed. It just changed from one form to another. And really, that's the big secret. Energy is constantly on an adventure. It's moving from place to place, changing from chemical to kinetic to thermal, but the total amount of energy in the universe, that stays exactly the same. It is the ultimate rule follower. And here is one last mind-blowing thought for you. The chemical energy from the food you ate, which is now making your heart beat, didn't just appear today. That energy has existed for billions of years. Maybe it was in a star, maybe a plant, maybe even a dinosaur. It has been on an unbelievable journey to get to you. So the real question is, where will it go next?